Hello and welcome to lesson 10.1. Today we're going to look at areas of parallelograms. More specifically, we're going to look at finding the areas of rectangles and finding the areas of an actual parallelogram. And just as a reminder, when we're talking about the term area, remember that we're looking at finding the number of square units a figure encloses. So if you look at this rectangle over here, you can see that we essentially divided this rectangle in half lengthwise and then in fourths vertically. So if we were to go and count these, we would see that we have 4 units, and by units I mean it could be feet, inches, centimeters, whatever, by 2 units vertically. So here you can see that if I wanted to find the area, I could count the individual squares. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 square units would be one way to do this. But mathematically, because this is a rectangle, which is a special type of parallelogram, we could also use a formula. Now the most common formula, I believe, would be to say that A equals length times width. Okay, so length times width, and it really doesn't matter because we're multiplying. If you want to call this your length and this your width, okay, or vice versa. But essentially you're going to multiply those two side lengths. So you would have A equal the length, which we said would be 4 units, times our width, which we said was 2 units. So I do get 8 here. Or we have this other formula here that is sometimes used, and it says A equals B, which is base, times H, which would be your height. So if we did this, found the area using this formula, our base would still be our 4 times our height, which would be 2. So I still end up with 8. Now the key thing that you have to remember on this, okay, is you have to include units. So your units, anytime you are finding the area, is going to be units squared. Okay, and I'm going to write this down below. So units squared, or you could write it out as square units if you wanted to. And what this would look like, so if I have, let's just look at a quick example. So if we had feet, let's say, it could be feet squared, inches squared, centimeters squared, millimeters squared, whatever the case is. These are examples of units, and anytime you see a unit raised to the second power like that, you should automatically know that that's a unit of area. So let's go ahead and take a quick look at how this would work in an example. So for example 1, it says find the area of the marching band's rectangular banner. So if you're given a story problem and it doesn't give you a picture, I highly suggest that you draw a picture. So it's kind of hard to see, but you have this rectangular banner over here, and you can see it right here. And it says that the width would be 7 feet and the height is 1 yard. Okay, so right away, because the 2 units are not the same, I would convert them. Okay, so if you recall, or if you have your conversion sheet in front of you, okay, we know that 1 yard is equal to 3 feet. So I'm going to redraw my rectangle now, and I'm just going to relabel this as 3 feet by 7 feet. And now that my units are the same, I can go ahead and find area. Remember, area equals length times width. So I'm going to plug in my length of 3 feet. And I'm going to multiply it by my width of 7 feet. And when I do this, this is going to give me an area of 21 feet squared. And this right here is my final answer. So now if we look at the area of an actual parallelogram, it says the area of a parallelogram is the product of any base length b and the corresponding height h. So here's just a couple different types of parallelograms that you might see. The b and the h in the red and all of these are just different ways that they could give you the base and the height lengths. And just know that the length of the base is b, okay? So you can see, and that b right here could have been given down here. Sometimes they give you like a side base length, okay? It says the length of the height h is also called an altitude. So you'll hear that term sometimes when you're dealing with geometric shapes, is the altitude of an object really means that it's the height, okay? And altitude is defined as the line segment that's perpendicular, which means it forms a 90-degree angle, to the line containing a base of the figure, and it's drawn from the opposite base. So notice that the height goes from one base to the other, and it's always going to be perpendicular on one of them. And then when we find the area of a parallelogram, we are looking at area equals base times height. So very similar to that of a rectangle. So for example 2, when we were told that we need to find the area of each parallelogram. So if I look at the one here on the left, I see that I have a base of 3.5 and a height of 8. So if area equals base times height, my base is going to be 3.5 inches, and I'm going to multiply that by the height of 8 inches. And now all I do is I multiply that out, and I see that I get 28 inches squared. And you have to include your units. And that's the area for that parallelogram. Now over here on the right, it's very similar. I can see that my 3.5 here is going to be my base. My 8 is going to be my height. And again, even though it's drawn a little bit differently, I have my area is equal to my base of 3.5 inches times my height of 8 inches. And this gives me again 28 square inches. Okay, now example 3 looks a little more complicated, but it's actually just the same thing that we've been doing all along. So for example 3, it says find the area of each shaded region. Assume that all angles that appear to be right angles are right angles. Now when I look at this image here on the right, I see that I have pretty much a rectangle. If I could enclose this little corner in down here, which I'm going to do just to and I'm going to do it with dash lines just to show you. So if I do that, then I see that I have a rectangle that has a width, so I'm going to put W there, of 8 and a height or a length of 4. So I'm going to call this my length here. If I can, on my screen it's a little bit tight, so I'm just going to put an L here for length. Okay, so if I go to find the area and I'm going to put big for the big rectangle, I see that I have 8 feet times 4 feet, which is going to give me 32 feet squared. Now I have to cut out 2 small squares, and these both have the same dimension. Okay, so I see that I have this square right here, which is 2 foot by 2 foot, and then I have another square over here, which would be this one, which is also 2 foot by 2 foot. So I'm going to say the area of a small square is going to give us 2 feet by 2 feet, which gives us 4 feet squared. And remember, I have 2 of those. So if I want to find the area of the shaded region now, so I have area, and I'm going to put of the shaded region, this is going to be 32 feet squared minus my 4 feet squared minus another 4 feet squared. So then I essentially have 32 minus 8, which is going to give me 24 feet squared. And that would be the area of my shaded region. Now you can try this image over here to the right on your own. So here I'm going to do the area of the big rectangle. So I'll put a B for big, and that is going to be 7 meters times 4 meters, which gives me 28 meters squared. Then I see that I have this region right here and this region right here. These are essentially two triangles that make up a square, and I know that they're square because they have these lengths of 2.8. So I'm going to assume that that's a square that looks like this with a side of 2.8 and 2.8. So now when I find the area of my small, I can see that I have 2.8 meters times 2.8 meters, and this is going to give me 7.84 meters squared. So now when I want to go and I want to find the area of the shaded region, I'm going to take my 28 meters squared and I'm going to subtract 7.84 meters squared from that. And then I end up with 20.16 square meters. And that completes this problem. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.